Right, what I've got to do now today is I've got to find a way of powering this and getting it to turn. So what I've worked out to do, I've got this rubber caster which I'm going to detach from here, and I'm going to mount it on this motor and spring mount it so that it runs on the inside of there. I'll have to work out calculations. I want this to be a 1 minute cycle on this wheel, so I'll work out the radius of this wheel, work out the radius of this caster, and then the proportion between them to work out how fast I want the motor to go. So I may have to swap motors for a slower or faster motor. I'll have a look when I've just done the maths on this. So that's my next job. So let's find a measure. Okay, so my wheel is approximately 250 mil diameter. This is 35 mil diameter. So I need to divide the 250 by 35. So it's 7 times smaller. So I want it to run 60 seconds. 7 goes into 60, 7 nines are 63, so 9. So approximately 10 revs per minute I need. That would do, that'll run slightly faster than 1 minute, so I'm happy enough with that. So I need to find a 10 revs per minute motor, or alternatively tune the motor down with a timer. Yeah, I've got a 10 revs per minute motor. So 10 revs per minute motor will make this turn about 52 seconds, something like that. Good enough for me. Right, let's get on with this. Right, so it looks like I'm going to need to mount this on the side because the spokes are going to get in the way, so it'll go there, and I'll mount it onto this side side of the fork. Obviously the further out that this goes, the slower the wheel goes, because it's having to turn more to get it to do a complete revolution, so it's better for me if it actually goes further. I think that's fair. There would be an argument for putting it on the outside here, but these are going to have the welds on, and I'm worried that the welds are going to cause problems, so just keep it on the side out of the way. Okay, so we've now got this mounted with a wheel. I've roughened it with some sandpaper, and it's mounted, correctly. I've now soldered the wires on, and this is part of the original electric window parts for this. So I think I would be better to spring mount this onto the side of this rather than just mount it, because it could end up slipping, or I'll have to push it so hard against it that it's not going to really work properly. So the next job is to find a way of mounting this so that it's spring mounted on a swivel. So probably think that we're going to end up with some sort of peg here, a hole drilled through this, and then some sort of spring to push it. So that's basically what I've got to do next. Okay, so what I've cut the plate short, I've welded the handle of a fork onto it, welded a nut onto the handle, and welded a bolt, so this will now swivel. So if I bring this closer, hopefully you'll be able to see how it's going to work. So I'm going to weld that bolt on there. I had it in the right position just now, like that. And then I'll put another bar above it with a spring going onto this to hold it onto it. Or the other possibility is maybe even putting a spring, like a pull spring, down onto that down there, or even having a post and have it there. So next job, weld this here. Yeah, the welder is kicking up quite a bit of, it's sparking and not working properly, and the reason for that is that the parts that I'm welding are zinc plated, and the zinc interferes with that welding process, so it makes it sort of fizz almost as though I'm not using any CO2, but it does actually hold okay, so it should be alright. Right, so now the next thing is to find a way of getting a spring onto it. Right, so I've just drilled a hole in the plates to hook a spring onto. I have loads of springs here. I'll grab sort of just a medium-sized one. I don't want something with too strong a pull on it because it will cause friction and give me problems. So we can then hook that on there. And then I can work out where to put a bar that holds this on. It's really not going to have to be that strong. So I reckon just a bar just coming straight out like that will hold it in place. Right, and of course if this is too tight, I can bend the bar back. If it's too soft, I can pull the bar away. So now it's a case of try it and see if it runs the wheel. I'll move these wires away so that they don't get caught. Right, that's the wrong way. That looks pretty good. So now what I can do is test. Maybe for some reason that's not. Right, that seems quite slow. So what we need to do is calculate there. Okay, so one revolution is 40 seconds. That is a little bit fast for me. I don't think that's long enough for it to do what it needs to do. So I'm going to need to maybe get something like a 6 revs per minute motor. I mean, the other thing I can do, I think I have got a speed controller somewhere, but to be honest, I think I prefer just to gear it instead. I mean, another way of doing it would be to get a smaller rubber caster. The other thing is, I feel that this is maybe pulling slightly too hard. Yeah, that's a slight problem. I think it should be okay. It depends if too many of the... I think we'll bend that back away again. That's better. Putting quite a bit of pressure against that. That should be fine. I mean, the other thing I can do is I could actually roughen all that up as well, and that will increase the friction. Right, I've still got the problem of the wheel only doing a rotation in 40 seconds instead of a minute, and I don't think that 40 seconds is long enough for the arm, for the window to go down, the arm to come up, the arm to go out, the arm to wave up and down, and then come back, and then the window go back down again, back up again. So what I'm going to do is I'm going to attempt, through putting this next to the angle grinder with a flat disc on it, reduce the circumference of this, the diameter of this drive wheel, because obviously if I can reduce the size of the drive wheel, it will have to turn more times to make the control wheel turn. So this is what I'm going to do. We'll give it a go. Considering this is rubber, I get the feeling it's going to be very smoky in here in a second or two, so I might have to put the extractor on. Okay, I may have just thrown away a wheel, we'll see now. I'll put it back on, see if it runs. It's not looking good though. It's looking a little bit lopsided, so Lord knows what's going to happen, but you know, without trying it, you just won't know. It might have been that the flat disc was just a little bit too fierce. Or it might have worked, we'll see now. Let's give it a go. Okay. Well, it seems to be working. So what I can do now is time how long it takes for one revolution. That's 50 seconds, just about 48 seconds. So I'm going to have another go and do it again. Oh, it is badly off centre. I mean, it doesn't really matter because it's on a spring. Got quite good grip now though. Stop. 38 seconds past. So it's still about, yeah, it's still 10 seconds, still 50 seconds, and I want it a minute. So I'm going to have to say. So that's now as small as it's going to be. If it's still running too fast, then it's going to be a case of buy a motor that turns sort of 5 revs per minute or something. So now I'm going to get on with the rest of it. Okay, so this wheel now is as small as it's going to get. I won't put it any smaller because it is pretty much, I would have said, optimum. If it goes any smaller, I could have other issues. So if the wheel is still turning too fast, which I'll find out once I've done the rest of the sequences, it'll be a case of getting a motor which has only got 5 revs per minute instead of 10, or 6 or whatever I can get. And that way I can make the wheel run at half the speed and run for twice the length. So I'll get on with the rest of it now.